a fireworks rocket is fired from the ground level. Its height in feet after t seconds after the launch is given by this equation. During what time interval is the rocket higher than 816 feet? So the height as a function of time is given by this parabola that opens downwards. So roughly speaking, in our head we should be thinking it was fired from the ground. If it's a parabola opening downwards, because it's a negative 16 in front of the t squared, it's going to look something like that and probably fall down. And they want us to know during what time interval is the rocket higher than 816 feet. So at some point we must have 816 feet. And we're interested in finding during what time that happens. So between these values, whatever they are, the rocket will be above 816 feet. So this is what should be going on in our head. And then we have to actually go find the values that make this happen. So first, let's go use our TI calculator and the intersect feature to figure out what's going on. But let's also keep in mind mathematically what this is asking. It's basically asking us to find when the height is going to be higher than or greater than 816 feet. That's what the question is asking. When is the height greater than 816 feet? Well, what is the height? How is the height described? It's described by this business over here. So I have 320 t minus 16t squared, and it has to be greater than 816 feet. So the height has to be greater than 816 feet. So I can look at the height as y1 in my TI calculator, 320 t minus 16t squared. So my TI should give me an accurate graph of the parabola opening down. And then I can look at my y2 as this 816 guy, which is just a horizontal line going through 816. So I'm looking at two functions basically, and I want to know when this guy will be higher than this guy, which will happen right here. So let's go put these two into our TI. Okay, so into my y1 I have 320x minus 16x squared because the variable used is x here. And inside, in the y2 location, I input 816 for the horizontal line that we know we're going to get. Now if I push graph, it'll give me the standard window and it won't capture the aspects of this graph. I do know that my y2 is going to go up all the way to 816, so I might as well go play around with the window and just look at quadrant 1 because time will remain positive and the height will remain positive. So I'm going to go from 0 to, let's try 50. I'll play around with it. And y minimum I'll keep at 0. And y maximum, I know I need to go up until 816. I'm just going to go up to 1000 and see what happens. Let's push graph. So better, I can see the parabola and I can see the horizontal line, but I don't need all these other x values. I'm going to make that smaller and I'm going to go higher on the y values so I can see the top of the parabola. So I'll go back to window. Maybe we'll go to, let's say, 25 for the x or the t values. And let's go up to, let's say, 1500 and see what happens. Okay, that's better. I have a pretty good idea of what's happening. We did say that we would get a parabola opening down. So basically this rough sketch that I did, I have here also. Let's go label some axes so we have an idea of what's going on. So I'm looking at the t-axis or the time and the h-axis or the height. T-axis and the height for the h-axis. And I need to know what this ordered pair is and what that ordered pair is so I can figure out in what time interval it stays above. I know I can't see the top of the parabola. Maybe we should go change the window to, let's say, 2000. So we see pretty much what we had guessed we would see here. Now in order for me to find this ordered pair and that ordered pair, so basically this guy right here and this guy right here, I'm going to go ahead and use the intersect feature of your TI. So I will go to second, trace, and you see the word intersect, item 5, selected. Now it says, is this the first curve you're interested in? Say yes, so I'm going to push enter. Then it jumps to the second curve, or in this case line. It says, is this the second one? I'm going to say yes and push enter. Now it says, do you want me to guess where they intersect? I'm going to say yes. And it gives me that ordered pair. The t or x coordinate is 17, and the y coordinate we already knew would be 816. So let's make a note of that. So I made a note of it here. Now I know there's another intersection point. Let's go to that one. I'm going to go back to second, trace, push 5 enter, or just the number 5. Now I have to arrow over and get closer to the other intersection point so the calculator can know what to do. Otherwise it'll go back to the same intersection point. So I'm going to get closer to this intersection point. Is that the first curve? Yes. It jumps to the second one. Yes. Do you want me to guess? Yes. And it gives me that the intersection point is at 3, 816 for the y, of course. So the second x value, or the smaller x value, is 3. Let's make a note of that. So graphically, for what time interval is my height more than 816 feet? We know it happens right there or here since I can write on it. So it has to be greater than 816, not equal to it, because it said higher. So I should really have open dots and shade in between. So from immediately to the right of 3 seconds all the way to 17 seconds, it looks like my height will remain greater than 816 feet. So we use the graphical method to figure out what the time interval would be to keep this rocket above 816 feet. Now let's go look at it algebraically. So this is the inequality I'm supposed to focus on. I'm supposed to algebraically find when 320t minus 16t squared will be greater than 816. Remember, it's a quadratic inequality. I have to get a 0 on one side first. So I'm going to go ahead. You have the option of either subtracting 816 from both sides or moving these two guys to the other side. I always like my leading coefficient to be positive, so I think I'm just going to move everybody to this side. You don't have to do this. You can move the 816 to the left and then deal with the negative later, but I'll do this. So these guys are gone. I have 0. I have 816 minus 320t plus 16t squared. So I can avoid dealing with a negative leading coefficient. Now I would rather put this in descending order so that I have t squared, t, and then the constant. So I'm going to write 16t squared minus 320t plus 816, and all this business has to be less than 0. So I didn't flip any inequalities. I preserved exactly what this was. I just rewrote it like this. All this business has to be less than 0. Notice the mouth here opens towards 0. I preserved that. I kept the mouth of the inequality opening towards 0. So I have to find when this stuff is less than 0. The numbers are pretty big. Let's see if we can maybe divide some factors out so we can deal with a factoring problem that's easier. We already kind of know what the factors should be because we did it graphically. Let's say we hadn't done it graphically. What would we do? It's a good review of factoring or the quadratic formula. They're all divisible by 16, so I'm going to go ahead and divide everybody by 16. Both sides of the inequality. That's going to give me t squared minus 20t plus 51 less than 0 divided by 16 is 0. I did not divide by any negative, so I preserved the inequality. had you moved this guy to the left, if you chose to divide by a negative 16, you would have to flip your inequality. But in this case, I didn't have to do that. So now the numbers are much better to deal with. We're going to go try to figure out this, if we can factor this guy out. See if we can come up with two numbers that multiply to 51 and add to negative 20, which means both factors should be negative. It looks like we have t and t, and negative 3 and negative 17. Negative 3 and negative 17 give me negative 20 if I add them. Negative 3 times negative 17 gives me a positive 51. So again, if I'm doing this algebraically, I need to find the x-intercepts of this parabola, and that's why I went ahead and factored it. If you had used the quadratic formula on this, you would have also gotten the same two answers, 3 and 17. But in this case, for the x-intercepts, so step 1 was to get a 0 on one side. And step 2 is to find the x-intercepts of this parabola. And we know that if I think of that parabola and let the y be 0, exactly equal to 0, the two t values that give me that are 3 and 17. And then step 3 was test your region, so I have 3 and 17 somewhere down the road. Again, I'm doing this mainly algebraically. So I have three regions, region 1, region 2, region 3 to test. Remember, you can do the sign chart and go figure out what the signs would be by choosing maybe a 0 in region 1, maybe something like a 4 or 5 region 2, something like 20 in region 3. Your choice. Or we can sort of cheat and look at this parabola and know that this parabola, the way I have it right here, is a parabola that should open up because the leading coefficient is positive. So if you had the leading coefficient negative, it would open down, but your inequality would be opening a different way had you chosen to do it that way and keep it as a negative. So in this case, in the background, I'm thinking something like this is going on. Two x-intercepts of 3 and 17, and my parabola opens up. Now when are the signs, the y values positive? Here the y values are positive above the x-axis. Here the y values are negative below the x-axis. And here the y values are positive. So again, you can test the regions by choosing numbers, or kind of cheat and know that you'll have a positive, negative, and positive in this case. Now what does the problem ask for? Once I set it equal to 0, the problem basically told me to find stuff less than 0. And if I'm looking at stuff less than 0, I have to keep the negative y values. Because when are the y values less than 0 means when are the y values negative. Well, that happens right here in the middle region because that's where I had a negative. So I'm going to shade everything in between. And since there's no equal sign, I'm going to have them open. So my solution basically is walking left to right in interval notation. I start at 3, comma, I stop at 17, and since there's no equal sign, I have open circles and they're both parentheses. So the t values that satisfy this inequality, the very first one I started with, I went through all these steps, and ultimately the solution I got was between 3 and 17 algebraically. Now if we go back and look at what happened graphically, I have the same solution between 3 and 17 seconds. So either way you do it is fine. This is much more visual and you can pull out exactly when the height will be above 816.